All right, we're going to verify the mean value theorem here. We're going to start by showing that the conditions of the theorem are met. And the conditions are, so one is f of x continuous on -2 to 2. And the answer is yes, this is a nice function that doesn't have any asymptotes or jumps or holes or anything like that. So it's a polynomial. It's definitely continuous. So that's a yes. Is it differentiable on the open interval from -2 to 2? And yes, it's differentiable for the same reasons. It's just a nice function. There's nowhere for it to have a cusp or a point or a jump or an asymptote or something like that. So it's continuous, it's differentiable, and the interval is closed, -2 to 2. That's the third condition. -2 to 2 is closed. Yes, all right. So the conditions are met. The conditions of the theorem are met. So what are the conclusions? Find a point guaranteed by the theorem. The theorem is an existence theorem. It tells us that something exists. In this case, it's telling us that a certain point exists, and that point is the point where the function has a certain slope. This is the average rate of change of the function over the given interval. This is the slope of the secant line connecting the endpoints. So that's f of 2 minus f of -2 over 2 minus -2 equals, so f of 2, this is our f of x here. Let's put a copy of it down here for reference. So what is f of 2? If I evaluate this at 2, we have 2 cubed is 8, times 2 is 16, minus 6 plus 1, so 11, minus, and the same thing at -2. -2 cubed is -8, times 2 is -16. I think I evaluated that wrong. Let's see here. 2 cubed is 8, 16 minus 6 plus, oh no, it's 11, okay. So -16 plus 6 is -10, plus 1 is -9. So minus -9 divided by 4 is 5. So the slope of the secant line connecting the endpoints of this function is 5. That's the average rate of the change of this function on the interval from -2 to 2. Now, the theorem says that there's some point in between -2 and 2. So the mean value theorem, somewhere in the -2 to 2 interval, f of x must have a slope equal to this average. Okay. So we're going to look for that point. We have our function. To talk about the slope of it, we'll need the derivative. That's 6x squared minus 3. And we just want to set that to 5 to see where this is happening. So we have 6x squared equals 8, which means x squared equals 8/6 or 4/3, which means this happens at plus or minus 2 over the square root of 3. Both of those points are happening inside this -2 to 2 interval. So there are actually two places where the mean value theorem is satisfied, at plus or minus 2 over the square root of 3. So we verified that the theorem holds. We verified the conditions. Therefore, the conclusion must hold, and we found out where the conclusion holds. It holds at these points, plus or minus 2 over the square root of 3.